Hello, and welcome to our SIG Node weekly meeting. Today is July 9th, 2024. Welcome. We have a few items on agenda, and Casey has the first one.
Thank you, Sergey. Okay. So this is effectively a KEP to allow certain node labels to be exposed on pods through the downward API. There was initially some security concerns around this, and what effectively the idea is, we want to keep this as safe as possible. The way we're planning on doing so is to only allow labels on the nodes through the downward API that have topology.k8s.io/something. Now, in reality, the way this would work is actually the exact same as it works today with the downward API for getting labels from environmental variables through the downward API. You would be able to do the exact same thing for the node, as long as it was prefixed with topology.k8s.io. And this would be basically like a key string interface to get some kind of label from there. And then likewise through the mounting of volumes. But effectively, the idea is you just prefix with node.metadata.labels. It seems like this is not really reinventing the wheel. All the logic is already there. Seems like the safety concerns we'll be able to address them if they come up, but we only want to do this for a subset of the labels. And I'm actually representing a colleague of mine today. We had an internal hackathon where we basically picked something to work on, and this is something that we need internally for our folks that are working on Kubernetes clusters in the field. We're like, consulting type things. So I guess what I was hoping to get out of this first item is to get I believe there needs to be an approval for this to be tested. And I'm hoping to get the approval, but I also am not sure that the right people are here. So really just here to listen and write down notes in case there's something I need to do.
Donny, I see you unmuted yourself. Do you want to comment first? Or... Okay. So yeah, how planning works in Kubernetes is we have releases, and right now we work in 131, and we locked on a number of caps we accept for 131. So we cannot take it for 131. However, I'm happy to, I think it will be nice improvement for 132. And schedule for 132 will be published later. So it will be somewhere in September. We will have cap discussions and stuff such. It doesn't say that we cannot work on cap right now, and I think what's important right now to get initial feedback on this idea, like whether node labels limited this way is all people need, or it's a good first step towards a proper design. So I from my perspective, I see no objections with that. Like it's a really nice improvement. My only worry will be, and something that may be needed to be addressed in the enhancement, is whether people will want to cheat and start using topology labels in some shapes that wasn't intended for topology. So like, oh, this label can be used as downwards API. Let me put like a security token there, kind of thing.
Yes.
We can discuss that, and maybe even if you only have something hard-coded, then people will abuse it. If you have something configurable, people will try to go through channels to configure it. So maybe like extended configurations that may not be part of a first iteration may be a good way to eliminate this concern, I think.
Very valid point.
Is there any other comments on a call immediately, like knee-jerk reaction?
Can you hear me now?
Yes.
Okay, thanks. So my top response is like what Sergey said. I don't have the big concern, but I do I do think about we need to first get the approval from the SIG auth. I think maybe start that conversation for security concern potential. That's on the node, SIG node. If the security don't have the concern, I think this is kind of at least I see use cases. This is acceptable for the node perspective. Can simplify a lot of usage. Another concern it is, can you maybe in your CAP you already described. I just want to make sure the use cases document very well in that. So then the CAP process when we review and will be easier for us to process those use cases, understand what how potentially people can using, and the implementation will around that one, right? So that's kind of good. Otherwise, we'll slow down the process normally. Yeah.
Great input. I will do that. Absolutely.
Okay, is there any other? Okay, Tim.
Node labels are mutable. I'm wondering if there's any potential concerns. I don't know if the KEP already addresses this, but it would be good to kind of make sure that there's a section in the KEP discussing like what happens if what the expectations are around labels changing after a pod is created.
Absolutely. There is something that mentions that here, and I think it's around a non-goal, and I don't know, and I agree with you, right? They're mutable. People can change them, and they're going to look at their pod and they're going to say, hey, like, what's going on? And I don't know how we want to address this, right? I think it's really open-ended right now, and so I'm like open for anything. But I said it was a non-goal, like, for instance, a config map might be mounted and it might change, and it might, you're not going to like get an update in your pod. So I feel like it may go along with the behavior, but if we want to like maybe look at solving that a different way, but it is listed as a non-goal. So I don't know if that answers your question.
Yeah, I think it might be something that we can solve with documentation.
Okay.
I think one concern is like if a container is restarted, then it could end up restarting with a different value. And I could imagine an application getting into a bad state from that. If there's like some state that's persisted across the restart and you end up with an inconsistency there. Config map volumes actually do get updates if the config map changes, but not environmental variables. So yeah, I think that would be a good thing to clarify too, is if you're mounting it to a file, is it going to be updated when the label changes? But yeah, I'm not sure it needs a technical solution, but I think being really kind of make sure that we kind of specify exactly what the behavior is and make sure that gets documented, I think would be a good first step.
Perfect. And so I'll write that in the KEP that we're going to document a lot of this behavior. Would that address it? Okay.
Yeah, I think so. And then even just kind of clarifying what the behavior is around container restarts and file mounts.
Got it. Okay. Thanks.
But all these things, they will need to be tested, correct? So there are some things that are going to be test cases for all this.
I agree. I imagine so. A lot of testing, many unit tests, and I have one integration test, but there's not an official PR yet. But I agree, like definitely very, very well tested feature should this be accepted. Eduardo, do you want to go ahead?
Yeah, on the allow list being configurable, I wonder, is there a way not to turn this KEP into a CRD KEP right? Because that kind of like will mean that we need a CRD to configure what we allow on the node metadata labels of the downward API, right? Like how can we configure that? Would that become like a flag to the kubelet or something?
Yeah, sorry, I just answered that. I was answering it in the chat when you started
do.
talking. I think a flag or part of the and part of the kubelet configuration is how I'd expect that to work.
Okay, then I think this KEB needs to also document the changes that we're going to add in, like extra flags to the kubelet, right?
Okay, I think we gave a lot of feedback. Casey, this cap is not as easy as it sounds. So you took a challenge on yourself. So if please follow along, and we will do our best to accommodate. But again, I think it's like improvement of life caps that may take lower priority sometimes and something more critical, but definitely many people are interested in that, and Kubernetes will be much better with this feature.
Great, thank you all for the feedback. We'll keep iterating, and I'll keep answering questions, and we'll get it fixed whenever there's time. Thank you.
Okay, next, Harsha.
Thanks, Sergey. Are you able to hear me?
Yeah, we can hear you.
Thanks. Sergey, can you make me host?
Yep.
Thank you. Let me share my screen. Give me a second. There is a Okay. Are you able to see my screen?
Yes.
Oh, okay. Okay. So this issue is about this comment here we have where this user essentially, this is quite old, if you see 2021, and they are claiming that effectively the way we reserve CPU for system critical demand, like for system slice, is not correct. And they give a very good description of how effectively it doesn't work properly. And so looking at this, I clicked this
I
spreadsheet.
only see pieces of your screen because of maybe Zoom. Is it
Oh,
just
okay.
for me or for everybody?
Same for me. I thought it was me, but yep, it's yeah. You only
Do
see a
you
couple
see?
of strips. We only see a couple of strips. We don't see the entire screen.
Okay, let me try stopping the share and try again. It kind of gave me error on my client, Zoom client, when I try to share, but let me see. See. It kind of gives me, my Zoom client seems to have issue here. Murad, do you or someone can you share and I can talk over it?
Yeah, it won't work for me. Anyone
Oh.
else on the call?
I can share if you send me.
Okay, so maybe first you can share the link on the agenda, GitHub link that I have, and then the spreadsheet that it attached at the second point.
Can you see it?
Yeah, I can see also the link. Yeah, here. So this link here, they talk about how the system reserve CPU calculated is not really correct in Kubernetes. And to give some examples here, so to break it down, I created that spreadsheet. So we go to spreadsheet, Sergey. So what it tells you is, number of cores and how much CPU systems reserve CPU we have been asked, the third column, this column C, and how much effectively you get in column J, right? So let's say if you start with row 2 here, we start with 4 CPU. We are using C group V1. So in C group V1, we use CPU share, and then we use some map to use the same logic to map that to CPU weights in C group V2. So essentially, the problem exists in C group V2 as well. So if you take the second column, there's 4 CPUs, and you are using C group V1, and by default, let's say you get 500 millicores of system reserve CPU. So what you do actually is you remove, let's say you have 4 CPU, that means you're going to remove roughly 3,500 millicores of CPU from your kubelet slice, right? So, and that's where it stops. But what ends up happening actually is you remove it from kubelet slice, but when the kernel calculates your share of CPU, it calculates the overall CPU share. So if you look at the column G here, the moment you remove the CPU share from kubelet slice, your total share goes down. That means as we progress on column H, I, and by the time you reach J, your share, your ratio is not changing much. So I'll give you one more concrete example. Take a look at the row number 10, like 96. So this problem is exaggerated on higher nodes with higher CPU. So let's say if you have a node with 96 CPU cores, you're on C group V1 and you ask for 1 millicore, 1,000 millicores of system reserve, right? You're going to remove that from your kubeflow slice. And by default, by the values for CPU slice and user slice at 100, 1024, 1024, and you essentially didn't do anything beyond that. So now the total is the sum of these 3 numbers. And if you see the ratio, you end up around 0.9896 on the column J worth of CPU core. Sounds good enough. But if you ask, if you bump the system reserve to 4,000 millicore, let's say the column number, the row number 12. So you went from 1,000 to 4,000. You should expect more system reserve CPU, right? You follow the same logic and you end up with 1.02 on column J. So that means user tried to bump from 1 to 4 and they didn't get what they wanted. It gets worse if the number of CPU cores increases. Now, however, if you use C group V2 instead, like say called row number 11, what happens by default in C group V2 is row number 11 will tell you the C group that's one. Yeah, that one. So where you go with same logic, you ask for 1,000 millicores, you end up with 2.45 worth of CPU. That's over provision. That's like user didn't even ask for it. That happens because by default system D adds the weight around 100 for where you don't assign anything. So that's calculation also incorrect. But if you ask for 4,000 instead of 1,000, that will be row number 13. You get 2.5. So that means initially you got 2.4 and now you got 2.5. So there's nothing much changed really from the actual CPU allocation. And that's what this comment is trying to highlight, that comment that we initially saw. Now, what happens that if you, this comment. So one more point I wanted to highlight on the spreadsheet, Sergey, there's a setting of kubelet called enforce node allocatable. And if you do that, it does exactly what it's supposed to. So essentially, it not only sets the values on kubepod slides, but it also modifies system slides. And now, if you see the example with 96 cores on V2, if you have 4,000, you got nearly 4 CPU worth of settings. So I think, I think we should consider this very seriously, especially on higher nodes. Either we are with C group V2 we are over provisioning, with C group V1 we are under provisioning, but in case of 96 CPU cores. And again, there's one more example with the 96 core. If you ask for 12 CPU cores, the last one, and you actually get 12 only if you have enforced node allocatable. So what we observe is sometimes when you have nodes with high number of cores and system reserve, even if you set higher number of CPUs to system reserve, we observe that they are getting starved. Like say your containerd cryo or kubelet are getting starved for CPU, and that's always a mystery for us. But this kind of helps us understand that that's not why it's happening this way. So my question to wider community is, am I making a mistake here? Because this looks like a pretty glaring bug to me. And should we consider making enforced node allocable calculation mandatory as a part of calculating for system reserve instead of having it a separate flag that probably no one uses? So that's what I want to gather feedback here. Derek?
Yeah, I'll jump in. So I think I wrote the original design for this, and I was trying to find it, and it predated KEPS, so it's a little hard for me to find. But you're right that the time slicing is relative to the peer, and then you could get misaligned ratios if enforced node allocatable didn't enforce on the system slice. With lower CPU machines, yeah, it wasn't a huge deal. There was hesitancy at the time, though, and there probably still is some hesitancy on turning the value on. Largely on those, I don't think we had a way of enforcing it for CPU only, but not memory. So if you reserve both CPU and memory, the flag when turning it on, I think, enforced both values, and we probably only want to have an option that lets you enforce the compressible node allocatable setting. So CPU, but not memory, just because the obvious side effects could happen around node stability. And then related to just node stability generally, like I'm not sure people are perfect on knowing how to size and measure their system slice usage, and so that's why it wasn't defaulting to true. And so my memory is a little fuzzy, so I can maybe try to find the document after, but it was somewhere in the Cube community repo before enhancements, and I got to remember where it moved. But that's kind of the history a little bit. So the practical impact of it is not clear, because these weights only really matter when there's a fully 100% utilized node, right? If no one in the system slice is actually trying to use CPU, like the relative weight didn't matter as closely. So the spreadsheet might present something that seems maybe worse than actual observed reality, but that's the only other thing to take note of. That the relative ratio only matters when the system is fully consumed.
Yeah, that's a.
Can I add some commentary in here? So our group is actually working on AI scheduling. So having it so that we can fully utilize the node does matter in those systems.
You mean you would have the system at 100% CPU utilization nonstop?
When you're talking about training, yeah, or HPC workloads.
Yeah, so like I said, then for that class of workload, like the flag as defined now would make total sense if you want to feel comfortable turning it on. You have to balance that with fully understanding like the overhead of the management component, in this case, the kubelet, with your workload. And so from the community standpoint, we took the let's be safer option, which was if you turn this on and people don't know how to size system reserve for memory and the kubelet caused your node to that would be upsetting. And then in general, we looked at the time when we did this for preemption capabilities to make it that when resources were low, that the node was always protected. So we tried to give bias towards things running in the system slice as a result. If I can find the original documentation, though, there is an option to put the kubelet in its own dedicated C group with the runtime. We actually had 3 slices in the design. So it was the workload slice, the Kubernetes runtime component slice, which was your runtime plus kubelet, and then just default system. I think, whereas we're all aware, not all Linux hosts have the same taxonomy, so it's a little hard, but we tried to give some flexibility at the time. And then networking daemons is the other thing that people need to be cautious about on how to size these things. But for the use case you're describing, I feel like it's totally possible to do what you want to do but it requires some diligence on your part to truly understand the management overhead for your workload.
Yeah, but I would like to add, I mean, that, and I had a question as well. In this case that you present here, have you done, I guess you haven't done like ISOL CPU for the kernel, and there are some things in Cryo that I have seen, the platform CPUs. So you can also achieve CPU isolation between cube system pods, and then this will help to reduce noise between your application and better CPU isolation. So I agree. I mean, there are ways you can also do in your system, like especially when you have this amount of CPUs or even more, there are some ways which can improve things and improve reducing the OS noise, which I assume here you don't do this kind of thing. You just have a default for everything, correct?
So I think, sorry, Don, for cutting it. So yeah, we are aware of the reserved CPUs, and that is an entirely separate scenario from when someone doesn't want a separation of the CPUs and they are okay with things overflowing in either direction as needed. So this is more on what happened on the default case. But you are aware that if you don't do this separation isolation, then it is expected that you're going to have yeah, of course. Yeah, of course. And then we have configurations where like folks can separate things out exactly as needed. Yeah, and Cryo has some nice features there. So yep. Yeah. Okay, thanks.
We do see these problems in our on our metrics. We monitor some metrics and we see workloads where nodes go to 100% utilization, where the system slice and the things running in system slice tend to suffer. And my main argument here is that we system reserve CPU column CR, you are asking user, allowing user to say, get 4,000 millicores of CPU, and if the system is completely used, they don't get that, and they get something else altogether, and which can be easily mitigated by simply having enforced node allocatable for CPU at least. Yeah, Don?
So thanks for this one. And I do observe that the behavior difference between V1 and V2, even like the recently, there are potential of also for memory management. So we found some problem, which is expected, but at least in the SIG node, we should really do this semantic changes comparison to see what's the difference, right? So there's definitely have the improvement, but I totally agree with the Derek. There's the history why we don't want to enforce, and we have that flexibility, all those kind of things. I'm also okay with to separate reserve CPU to some extent, to separate the CPU and all compressible or from the incompressible resource if we need it. But I just want to say that today's implementation CPU management, we are not ready for your 100% utilization. If you will notice that in today's implementation resource management, we do detect of the try to prevent the syswoom. We also try to prevent of the full of the disk, and we don't. From day one, we plan to implement of detect of the CPU starvation. We never finish that part because there's no in real demand in the in production, at least back then. So this is today's our implementation, we are not implemented that way, like the detect of the CPU starvation and the evict of some of the workload. We are not here. So I just want to warn people, just think about, once we have this enforce of the node allocable, then we can achieve that. I don't think about we are in that stage yet. There's the more complicated scenario on the node CPU management we need to consider if you want to achieve full of the utilization about the CPU.
All right. So do we agree that we need to handle CPUs separately? Let's say, would you be okay to have a flag which says enforce node allocatable only for CPU, something on those lines?
Yeah, I think it makes sense to do enforcement for compressible resources, but I also would say it should be something that you opt into, and then maybe it's safer to do when your workload is well understood. But I think having the flexibility for compressible versus incompressible resources is a nice enhancement. The only other thing I was thinking when looking at this was if there was something new around cgroups v2 that we didn't have available at the time. One of the things that strikes me is like usage of the user slice. Like I wouldn't really see a lot of processes on a typical Kubernetes node being run under user slice because you're not tending to launch your own relative processes. But I'm definitely open that we would do that. I'm really struggling to find the old design. I wish some stuff before like Cube 111 was easier to find. But
Derek, I'm wondering that as we have more and more beefier nodes, even on V2 or V1, the system reserve values you tend to usually go up as the workload increases. But no matter how much system reserve you reserve, like say I went from 4,000 to 8,000. If you don't do enforce node allocatable, the user actually doesn't end up getting what we find that we end up recommending to customers that, hey, you were seeing the system starvation, CPU starvation for systems like just increase the system reservation. They do that, and it will not make any difference to their situation.
I guess what I'm trying to separate here is like what people would recommend for their distributions or service offerings relative to node sizes and node flavors versus just ensuring like we have the right flexibility and knobs in place for like a wide variety of community users to do this. I'm certain if we turned on enforce node allocatable by default, that a lot of people's nodes would break because a lot of people don't set system reservations, nor do they set them on anything that's based on like historical usage. We used to have a tool that we ran to try to figure out reservations needed for particular pods per node boundaries. And even that we know is difficult to measure. So I'm just from my community hat on here, like if Mernal and I were talking with our Red Hat hats on, I might recommend something different for particular settings, right? But for this, I would say a nice enhancement is to distinguish between compressible and not for separate enforcement, and then the user slice. There's no capability inside Kubelet today to write any C group enforcement value to user slice, and I don't think it's an expectation of Kubernetes that people are running a lot of processes under it. You're typically letting the kubelet manage the workload. So that's that history I was just trying to share. The other thing I think, Donna, even when we think back on this, getting a uniform C group taxonomy is actually really difficult historically. And systemd and others, and particular container runtimes had different perspectives on how to pursue this. So that's why we had to leave the flexibility as we had them now to let people choose which C groups were placing which things and that type of thing. So
yeah, I think reading through, I think back then there was no uniformity and there were no guarantees that everyone is going to have the same layout. So it made sense, and I agree. Like we should definitely have opt-in here, otherwise we'll definitely break nodes. So
but
I
no
guess
opt-in for. Sorry, go ahead, Don.
I just want to comment on this one thing. I think that I totally agree with the Dark. This is the history why we build like this way, right? Not enforced and all those kind of things. But we could improve our document maybe through this by like the separate of enhancement enforcement for the different type of the resource, but at the same time also give some example the improve of the document and give some example based on the different use cases. So people can consider based on their production deployment and then to choosing different combination. Maybe that's the things. And also how the tool, using what kind of tool. I think I saw the doc before, maybe it's blog, and how to measure and how to use for your production deployment, how you are going to reserve. So those kind of can help from the community. Is that what you okay with?
Yeah, then the other category for memory, just for folks who are observing later or don't recall, is like sometimes memory wasn't always garbage collected or reclaimed as one would expect. And so like depending on how long the system ran, like enforcements were not things that you could depend on. So doing with incompressible is far safer. I would not recommend running memory enforcement on any environment because you don't want to starve the management component.
SQL v2 supposed to be better. That's kind of people argue with SQL v2, but I'm not sure. I didn't see the better so far, at least.
Yeah, and then just so folks are aware of like the related risks, like container image pooling could be slower on machines where you enforce this on CPU. There was a number of other side effects, like the issue we ran into at the time when this was going on and things are better was the polling loop between the kubelet and the container runtime could be starved, and so nodes would appear to go not ready when this is enforced. So it's just like a subtle thing we got to be careful on, and that's just how we are where we are right now.
Great. Thanks. Now, Sergey, I think we can move on to the next topic. Thanks, guys.
Okay, going to the next item is from Adil about logging. Are you here? Hello, Adil? Yeah, I don't see anybody with his name. I think I recognize most of other names. So, yeah, the question was about logging and how to enable just error logs, and Peter already commented there. So I hope that it covers it. And next item from Mihai.
Yeah, not much, just like a heads up about two things. One is the PR that is under review for like couple of weeks now, and I wanted to make sure that all comments are addressed and we can move forward. But so I scheduled the meeting tentatively, but I see already I'm getting comments. So I'm going to address them later today or tomorrow, and hopefully we can conclude the review. Another quick is I put in the agenda the link that we spot that some users under some circumstances when using jobs, they hit a scenario where kubelet can flip the face of a pod from succeeded to failed. And the scenario involves like some webhook that some transitions fail. Also involves like maybe the webhook is not even critical. The webhook is only important so that the job controller gets stuck. But what we found in all the cases is that there is a kubelet restart. And what we found in all cases that there is like node shutdown or something like this. But so I put more details there. but I mean, we haven't dig to the very bottom, so I hope that maybe in the community there are people who could see this, and you know, by some we can in a wider audience we can push the investigation if some people also see this issue. So that's from me. Go ahead.
I haven't looked at the issue yet, but my first reaction it is since the pod is terminated, shouldn't for release of that pod IP shouldn't that's the proper behavior, right? So we remove and reclaim release that pod IP, and I haven't looked at the issue in I just this is my first reaction here. So what's the problem caused because this problem? And also you mentioned that temporary remove is mean like the later is being put back. This is what confused me.
Yeah, so that's right. There was also this comment, I think, from Clayton, that why we preserve the IP. So I'm not sure exactly if this is needed, but this was the behavior like for many releases. And yeah, it was like that in 126, but the regression that was introduced in 127 is that there is one patch update, like additional update to the API server where we clean it, but later we restore it by kubelet. So this is definitely wrong. So I just in this PR restore the behavior of 126 that we keep it. But and I think it's worth like cherry picking back because this current behavior means also there is one additional request more sent, like wasteful. But I don't know, going forward, maybe we could clean it, but I was sort of afraid, but that it's a bigger change. And seems that there was also a comment from Antonio Ojea that it might be desired to keep it, even if it's stopped. But I must say I was driven mostly by restoring the behavior.
Okay, so okay, got this. But what's the problem cost? Do we know what's the problem cost?
Yeah, that with this change in 127, we set in the status manager the status that can be sent to the API server, and it is taken from the method that takes the status pod status from the stopped container, and the stopped container doesn't contain the IP.
So if I understand correctly, actually that temporary remove also by the node. The node later restore back for the same terminated part. Is that true?
Yes.
Okay.
It's
okay.
like both updates by kubelet. First kubelet sends the request that there is no IP, and then later it sends that there is IP.
Got it. Then in that case, it's definitely a bug. But how to fix that's the separate story, right? So because the same source and change the flip of the behavior. Okay, got it. Thanks.
Sure. Yeah, it's a tricky one. Like there are many comments, and I leave in the PR description. Like I was asked many questions regarding this, and I tried to put like summary, like to answer these questions. But yeah. Okay, so this is the update from me. Just the heads up about these two things.
Yeah, I commented on original issue about pod IP being lost, asking for business justification because I mean, if it's just flickering back and forth, I don't think it will justify the cherry pick. But if it's critical and bug was filed by Istio team, so it may be critical for some networking scenarios. In this case, we will need to cherry pick. So yeah, let's take it. Take discussion to GitHub and see what will be the update, and we will define the priority for this.
Okay, thank you.
Mark, are you around? You have 10 minutes.
Yep. Yeah, so this is just a request for a few more eyes to review a Windows memory pressure eviction pull request. I know Peter Hunt reviewed it, but yeah, I'd like to try and get this in if we can. It shouldn't change any behavior for Linux or anything.
Okay, is it just a request to review PR?
Yep. Yeah, I mean, I'm happy to answer any questions, but I don't think we need to discuss it here yet.
Okay, so just change the default. I mean, I generally feel it's okay. I can comment there.
Great.
Okay, before we complete, I want to say that we only have 2 weeks from now for code freeze. So if you're working on anything, please make sure that you have it scheduled for reviews and you notified reviewers and approvers for this PR. After code freeze, like I mean, original deadline was like a little bit tighter, but at the same time, like test freeze will be longer. This time, test freeze will be that long. So don't think that you will be able to sneak some tests after the deadline. Try to put everything in this 2 weeks and not rely on after the code freeze deadline to for any test code to be accepted. I mean, don't rely on that. It may be accepted, but like it's not something we will definitely do. Okay. Anything else? Going once? Okay, we have 8 minutes back. Thank you, everybody. Bye bye. Have a good rest of the week.